Welcome. Today we are going to see about interfacing of 16x2 LCD with Arduino Uno microcontroller. 16x2 LCD is used to display the informations what we are processing or what we are used to manipulating in our system or from the microcontroller where which get the data from sensor. For example, if we using IR sensor means if you using IR sensor means if the sensor detects object any object nearby means it will give the if condition. If the object is near than greater than 10 means it will have to indicate the object is very nearby our source. Like that, if you want to display our message means we can only display it on a display. So for that purpose we are using a LCD display, and in that LCD display for our convenient we are using 16x2 LCD display, which is very sufficient for basic projects. So in this 16x2 LCD display we are having like this. In this we are having 2 rows and 16 columns, 1 2 3 4 1 2 3 4 5 like that, up to 0 to 15 and 0 to 1, which means 2 rows 16 columns. Coming back to the topic, this LCD is very easy to interface with our Arduino microcontroller board, particularly in Uno variant. In that variant, with Atmega 328P controller, it is very easy to interface with it. Using this Arduino IDE, we can develop our project in this IDE itself. We don't want to use a compiler, and we don't want to make a preprocessor, and we don't want to use a translator assembler like that. We don't want to use separate entities for a single para of code, and we can use it use it in this environment itself for our complete development. We can also gain X file from this IDE itself, rather than using any third party X file creators, and we can also dump our code from here itself. From this PC to microcontroller, we can use this upload icon for to dump our code in the microcontroller in real time. Now we are going to see about LCD 16x2 LCD programming using Arduino IDE. This IDE can support C++ languages. With this embedded C++, we are going to write a 16x2 LCD display program. In that we are going to display a message that Kishore here. Like that, we are going to display a message. So for that we are using hashtag include liquid crystal.h header file, which means header file is a file which we have to declare it even before the main function itself, which means if you want to use any function rather than this inbuilt function, we have to declare it as an header file. We have to program separately in a program file, and make it save it as a .h format header file, and we have to include it in our current program, and we have to use the required parameters for the program to run and execute. While in other IDEs and other compilers, we have to write a separate file for this, but in this Arduino IDE, every library files are available. Every library files are available in this Arduino IDE itself. Like liquid, if you want to operate an LCD display, means we can operate just using include preprocessor derivative and macro, include macro and liquid crystal.h header file. If we declare here, means it can be usable, and in that file we having an LCD function which the LCD can be interface with these pins, like 12 is connected with RS, 11 is connected with enable pin, and 5 4 3 2 pins are connected to the data pins respectively. Like these pins. RS is for 12th pin. RS means register select. 11 and 11 for enable. We have to enable the display first. Before we are showing the information, we have to enable the display. And data pins for the data sharing purpose. Here VDD is for a positive voltage, and VSS is for negative voltage, and V is for ground. Coming back to the code, we are using two inbuilt function, like setup function and loop function. Both are void function, which means it does not return any values from these functions. We are giving lcd.begin, which means we are initiating the LCD display data, which means 16x2 LCD display. And with this clear function, we are clearing the informations which they have been already used in the display, and we are setting the cursor with the exact value 0, 1, which means first row and first column and second row. With this print statement, we are printing the statement. With this print function, we are printing the statement and giving a delay time of 1 second, and again clearing the above statement and setting the cursor at the second row, and again giving the again using the print function, we are declaring a statement that here, and again giving a delay function of half a second, and this process will be repeated because we are using in this loop function. Now we are going to verify our program. This ID is compiling our entire program and give the X file. See, it has done compiling. After that, we want to extract the X file. We can find the X file here itself. This is the X file format. We are going to copy the X file and going to Proteus. Proteus is used for software real-time simulation. Because of we going before the hardware real-time simulation. We can do it how the hardware is going to work. We are like a preview. It will be easy to work in the hardware real time using this Proteus. By checking verifying this progress will be end in our desired output. Now we are going to double click our microcontroller, control A, control V. We have loaded our X file here now and giving a OK, and then we are going to simulate our process. We are connected our pins to the required LCD pins and starting our program. See, it is showing Kishore. Here, after a delay, it's showing here, so it will repeat it. Thank you.